Welcome to the Deep Dive. We're here to cut through the noise on some really critical global topics. Today, we're embarking on a pretty fascinating deep dive. It's about the science and also the history behind nuclear power and weapons. We've gone through a lot of material, personal research, notes on uranium enrichment, timelines on proliferation. Our goal really is to unpack the science and show how it connects to, well, the whole geopolitical situation it created, hopefully give you a fresh look.
Absolutely. It's about understanding those core scientific ideas, but also seeing the global landscape that nuclear tech has really shaped.
Okay, so let's start right at the core. Uranium. When we talk nuclear, we often mean uranium-238. That's like the vast majority, 99% of what you find naturally. But the really crucial part for energy in bombs is uranium-235. It's an isotope, right?
Exactly. A variant of the element, different number of neutrons,
hmm
makes it unstable, fissile, that's key.
And here's the thing, natural uranium, it only has about 0.72% of this U-235. Tiny.
Really tiny.
And that small percentage, that's the bottleneck, isn't it? It explains why this whole industry is so complex and expensive.
It really does. And that leads directly into enrichment.
Right. How do you get more of that U-235?
Well, it's this incredibly complex, very energy-intensive process. Think of it like trying to pick out specific, rare grains of sand from a huge beach. You need specialized gear, centrifuges spinning like crazy.
And this process boosts the U-235 concentration.
Yeah, dramatically. From that natural 0.72% potentially, all the way up to like 94%.
Wow, 94%.
And we should probably mention anything over 20% is generally called highly enriched. That distinction is pretty important.
Okay, so from that science, we jumped pretty quickly to, well, reality, World War II, the atomic bomb, America, Oppenheimer leading the charge. That first test must have been something else.
It really must have been. The Trinity test, July 16th, 1945, New Mexico, and then very shortly after, the actual use in war, August 6th and 9th, 1945, Hiroshima and Nagasaki in Japan.
The stated reason was ending the war, right?
That was the stated reason, yes. And WWII. But our research also points to, establishing military dominance. And it all started, remember, partly from this fear that Nazi Germany might get there first. A real race.
So that first use, it basically kicked off a new era. Suddenly, having nuclear weapons seemed like the ultimate security guarantee. The U.S. wasn't alone for long.
Not at all. The Soviet Union tested theirs in 49.
Then the UK in 52.
France in 1960, China in 1964, the so-called nuclear club started growing.
And it didn't stop there.
No, it kept evolving. India tested in 1974, reportedly as a direct response to China's capability.
Ah, okay. Domino effect almost.
In a way. Then Pakistan followed in 1998, responding to India. It really reshaped regional power balances. And then there are others, North Korea, obviously. Israel is widely suspected maybe since the 60s, but never confirmed officially.
And South Africa? That's an interesting one.
Yeah, quite interesting. They actually built 6 bombs in the 1980s. But then, remarkably, they chose to dismantle them voluntarily.
Which sort of brings us towards the present day, and a question we see a lot in the materials. Why can't a country like Iran just make nukes? We hear they have uranium enriched to 60%. That sounds high.
It does sound high, and it is significant.
Yeah.
But getting from 60% to the roughly 90% needed for a weapon, that's not just another 30%. It gets exponentially harder.
Ah, okay. So it requires different tech, more energy.
Exactly. Different facilities, huge amounts of power, a much higher level of technical know-how. It's a major hurdle.
Which leads to efforts to control all this, right?
Sure.
Like the NPT.
Precisely. The Nuclear Non-Proliferation Treaty, the NPT, from 1968. That's the cornerstone. Its main goal is basically to stop the number of nuclear weapons growing worldwide.
And under the treaty, only 5 countries are officially recognized as nuclear weapons states.
That's right. The U.S., Russia, China, the U.K., and France. The ones who had them before the treaty was signed, essentially. Other countries that signed the NPT agreed not to build them.
So even with countries like India, Pakistan, North Korea developing weapons later.
Right, those are outside the NPT framework in that sense. But the treaty aims to prevent further spread. And our sources do suggest that overall, the total number of nuclear weapons hasn't been expanding in the way the early arms race suggested it might, largely because of the NPT and subsequent arms control efforts.
So wrapping this up, what's the key takeaway for you listening? Understanding this whole enrichment process, that 0.72% problem, it really unlocks why nuclear tech is so powerful, but also so difficult to manage. It sheds light on both the energy side and, yes, the weapons side, and these huge geopolitical efforts to control it all.
Yeah, it's this constant balancing act. And maybe a final thought to leave you with. We know the science is possible. We've seen the history. So how effectively can things like international treaties, like diplomacy, continue to navigate this? How do we keep balancing the push for innovation and energy against, the absolute need for nonproliferation and global security?